Okay, we have another Math Olympiad problem here. Let's see how we can solve this one. It is given a squared minus b is equal to 73, b squared minus a is equal to 73, and a is not equal to b. We need to find what a and what b. Let's see how we can solve this one for a and b. Let's label these like equation 1 and equation 2 first. Then let's see what happens if we subtract equation 2 from equation 1. If we subtract equation 2 from equation 1, we get here a squared minus b. From that, we need to subtract entire thing b squared minus a. And on the right hand side, we have 73 minus 73, which is 0. And let's distribute this minus. We eliminate parentheses by multiplying by the minus 1. Then we get minus b squared plus a, because minus minus will become plus. On the right, we have 0. Then if we write this minus b squared next to a squared, like that, and then plus a, then the minus b, we have the terms on the left-hand side like this. What we have here is a difference of squares. We know the factored form of this difference of squares is simply a minus b times a plus b. So let's replace that for this a minus b times a plus b. And here we have still a minus b. On the right, it is 0. Now, if we look at this term and that, and a minus b term is common for both. If we take that common a minus b out, if you want, we can put parentheses around this to make it more clear. It's the same thing. And if we take a minus b, that common term out of these two, if I take a minus b out of this term, another a plus b term will be remaining there. And if I take a minus b out of that term, another plus 1 should be remaining there. On the right, we have 0. We can always double check by distributing again by multiplying by a minus b. Both these terms will give us these back. A minus b times a plus b, which is that term, a minus b times plus 1, which will be plus a minus b. So nothing wrong with writing this like that in the factored form. This we can simply write a minus b times, here can eliminate parentheses, it's 1 in front, multiplying by 1 will give the same thing. So what we get will be a plus b plus 1 from that. Now we have a product equals 0. If a product equals 0 like this, then either this should be 0 or that should be 0 or both should be 0. It's called the zero product principle. So using that, either this should be 0, that means a minus b should be equal to 0, or the other factor, which is a plus b plus 1, it should be 0 or both should be 0 for this to happen, and which we write like that. Then if we solve this, we will end up getting a is same as b, because adding b to both sides. Clearly, at the beginning of the problem, it is given that a cannot be same as b. Therefore, this cannot be a possible solution. Then only piece that we are left with is this. Now, our aim is to try and find what is a and what is b. So let's use the piece that we are left with, which is a plus b plus 1 is equal to 0. So from this, if I isolate b on one side by subtracting 1 from both sides and also a from both sides, I will get b to be minus a minus 1, or 1 minus 1 minus a. Now let's label this equation to be like equation 3. And now that we know the value of b in terms of a and numbers, let's use that value for b in one of these equations that we have. Let's use equation 1. So using equation 1 and equation 3, substituting the value for b that we got in terms of a and numbers here for b, let's see what we get. We get a squared minus, for b it will be minus 1 minus a should be equal to 73. Then by multiplying by this minus, what we get will be a squared. I will write this term first. Minus times minus a will be plus a, and here it will be plus 1, will be 73. And we see we have a quadratic equation of a now. Let's try to solve that. That will help us finding what a is. Once we know a, we can find b from any of these equations that contain both the variables. So we have a squared plus a plus 1 is equal to 73. Subtracting 73 from both sides, we will get 1 minus 73 will be minus 72 here. So we have a squared plus a minus 72 will be 0 on the right once we subtract 73 from the right hand side. It's a quadratic equation in a. How to find a from this? We can either use quadratic formula, or this can be factored as well, or any other method that we know to solve a quadratic equation can be used. Let's try to write the factored form of this, and that will help us solving for a easily. Let's try to write down all the integer products that give me minus 72 when we multiply. 1 times it will be minus 72, and 2 times we will get another number. 3 times again we can get, 4 times again we can write like that. If you write all these numbers, the only product that will give you plus 1 when you add the two numbers in the product will be when you have 8 times 9, it has to be minus 8. Minus 8 times 9 will be minus 72. And also when you add the two numbers, minus 8 and plus 9, it will be plus 1, which is same as the middle coefficient here. So we can use these as coefficients of this 8 to the power 1 term and write the same plus a using these, and that will help us completely factoring this. So it's a squared. I'll write plus a by using these coefficients. 9a minus 8a minus 72 is equal to 0. Now we see one a term is common for these. If I take that common a out, another a will be remaining here, and plus 9 will be remaining here. Then we'll try to create the same term a plus 9 using these as well. How to do that? We can factor or take out a negative 8. Then only thing remaining here will be a, and here it will be plus 9. We can double check. Distributing will give both these terms back. Will be equal to 0. And then we see for these two terms, a plus 9 is common, and we can take that a plus 9 out. We take a plus 9 out, another a should be remaining there, and minus 8 from that term should be equal to 0. We have again a product equals 0 form. Then either this should be 0 or that should be 0 or both should be 0. Writing that a plus 9 should be 0. For a minus 8 should be 0 or both should be 0, which we write like that. From this, we can easily see A should be -9, subtracting 9 from both sides. And from this, we can see A should be 8, adding 8 to both sides. So we have two possible solutions for A that we found. Now, if A is -9, let's see what our B should be. Using equation, let's take equation 3. So using equation 3, if A is -9, B will be equal to -1, negative another -9. Negative negative will become plus. So it's +9 minus 1 will be 8. So if A is -9, B should be 8. So if A is -9, B should be 8. That's one possibility. And the other possibility is when A is 8. Let's consider that too. If A is 8, what happens? If A is 8, again from equation 3, we have B is equal to -1, negative A. A is now 8. In that case, B will be equal to -1, negative another 8 will be altogether -9. So when A is 8, we get B to be -9. So that's another possible solution. And we see that here A value here turned out to be the B value, and here B value turned out to be the A value. So like that, we can solve this problem. We have two solutions, possible solutions. A can be -9 and B can be 8, and then these will be satisfied. And also A can be 8 and B can be -9, and again these will be satisfied. A and B are not equal. We can double check by plugging these numbers in for A and B, and we'll see that both the equations are satisfied by these. So like that, we can solve that Math Olympiad problem. I hope you learned something from this, and please don't forget to subscribe my channel. We will see you again with another similar video soon. Thank you.